Okay. In order to determine if treatment X is successful in improving eyesight, a research study was conducted. From a large population of people with poor eyesight, 300 participants were selected at random. Half of the participants were randomly assigned to receive treatment X, the other half did not receive the treatment. The resulting data showed that participants who received the treatment X had significantly improved eyesight as compared to those who did not receive treatment X. Based on the design and results of the study, which of the following is an appropriate conclusion? Okay, so treatment X is likely to improve the eyesight of people who have poor eyesight. Let's see. Large population of people with poor eyesight seems reasonable, right? Treatment X improves eyesight better than all other available treatments. That's way too strong because we don't know if there are better drugs out there. Treatment X will improve the eyesight of anyone who takes it. Again, way too strong. Treatment X will cause a substantial improvement in eyesight. We don't know if the change is substantial, just that it exists. So A is the best choice. Graphs of the functions f and g are shown in the xy plane above. For which of the following values of x does f of x plus g of x equal 0? Okay. So what they're saying is that the y values, when you add them together, you get 0. So I could take that to mean basically you're an equal amount up on one function as you are down on the other function, so that if you combine the values, you end up with 0. So right away, I can notice that this is my area that I'm looking for, because the value of the height of the function here is 2. The value of the height of this function is negative 2. So they would cancel each other out, effectively giving 0, right? So I just need that x value. So it looks like if this is x equals 0, this is negative 1, negative 2. So x equals negative 2 is the x value that gives me that spot on the map. All right. So how will the quantity of product supplied to the market change if the price of the product is increased by $10? Okay. So looks like P represents price. So we're taking P to P plus 10. Okay. Let's see what would happen to the supply. So what I need to do is substitute P plus 10 in for P, right? So I'll have, instead of that, I'll have P plus 10. 1/2 is the same as divided by 2, right? Plus 40. And then if I divided each out separately, I'll have P over 2 plus 10 over 2 plus 40. And so I'll have P over 2 plus 5 plus 40. So I'll have P over 2 plus 40 and then plus 5. So I just switched those. The reason why is because this is the original amount. So it seems as though I've added 5 to the original amount. So the quantity supplied will increase by 5 units. That's answer choice B. Next, at what price will the quantity of product supplied equal the quantity of product demanded? So they want supply to equal demand. So I can just set the right-hand sides equal to each other. So again, I write P over 2 plus 40 equals 220 minus P. Okay, so now I can add P to both sides. So that gives me, I have 1/2 P and 1 full P, so that gives me 3/2 P. And if you find that hard to understand, you can just make this 2P over 2. And then it's 1P over 2, so that's 3P over 2. Plus 40 equals 220. Then I subtract 40 from both sides, so I get 3P over 2 equals 180, right? Next, I can move the 2 diagonally upwards, right? We could always move factors diagonally. I can move the 3 diagonally downwards here, and I'm left with P is equal to this. So now I can do the division first. 180 over 3 is 60. 60 times 2 is 120. So I get 120 as my final answer, choice B. Graphene, which is used in the manufacture of integrated circuits, is so thin that a sheet weighing 1 ounce can cover up to 7 football fields. Okay. If a football field has an area of this, so that's 1 field. All right, so let's make a list here. 1 ounce corresponds with 7 fields. 1 field corresponds with, let's make this 4/3 acres. And so the question is how many acres, so we'll use X, could 48 ounces. Okay, so this is my setup here. All right, let's see how we could figure this out. Well, for one, let's see. So let's start with 48 ounces, and let's try to turn that into acres. Okay? So we're starting with 48 ounces. Now we have to get rid of ounces. So to get rid of ounces, I need something with ounces on the bottom. So I use this first conversion factor here. 1 ounce corresponds with 7 fields. So that gets rid of ounces. Next, I would need to get rid of fields, so I would need to put fields on the bottom, and I would have to use this item here. So 1 field is 4/3 acres, right? And that gets rid of the fields, okay? They cancel out just like numbers would. So now I have the correct unit, which is acres, so my answer must be correct. So let's just run through the calculation. So we have 48 times 7 times, we need to do 4/3, so 4/3. That gives 448 acres. So let's see if that's a choice. It's very close to choice C, 450. Michael swam 2,000 yards on each of 18 days. The scatter plot above shows his swim time and corresponding heart rate for each swim. The line of best fit is also shown. For the swim that took 34 minutes, Michael's actual heart rate was about how many beats per minute less than the rate predicted by the line of best fit. So let's look at that 34-minute swim. So that would be, whoops. Okay. So that would be 34 minutes would be this swim right here. So let's see. Well, what is each mark going to be? I believe it's going to be 2, right? Because there seems to be 5 of them within a gap of 10. So you could take this subtraction and then divide by the number of intervals. So it seems to be 2. So that would make this 148 if we subtract 2. And the line of best fit hits the mark of 34 at 150. So if we subtract those, that gives us 2 as the difference between the expected and the actual. Of the following 4 types of saving account plan, which option would yield exponential growth of the money in the account? So exponential growth is when we multiply by something each time, right? So if we have amount, that would equal amount 0 times 1 plus rate to the time. And so this is the key equation, is that we're going to be multiplying by this, which is effectively a multiplier, just like if we were to do a percent increase, right? So let's see which choice has that. Each successive year, 2% of the initial savings is added to the value. So we're adding something each time. That is more of a linear situation. Okay. Each successive year, 1.5% of the initial savings and $100 is added to the value. Again, it seems like we're adding, right? Each successive year, 1% of the current value is added to the value. Okay. Each successive year, $100 is added to the value of the account. All right, so they all use the word added, so we can't go by that. So let's reassess. So the formula for linear is if we were to add, for example, the same amount each time. So if we start with A0 and then we add 100, and this 100 could also be a percentage of the initial. So it could be like 0.1 times A0, right? So that would be, if we factored it out, A0 times 1 plus the rate. But the key thing here is that the rate is not being brought up to the t power, right? So we're not multiplying it each time. Another way to look at it, the difference between the linear and the compound interest is, are we adding a percentage of the original, or are we adding a percentage of the current? So if you notice that this one has a percentage of the current value, so this is going to be our best answer, right? Because the other ones add a percentage of the initial value, and that is basically a constant number, right? So if the initial was 100 and you're taking 2% of that, that is basically $2, okay? So that number is fixed, so you may as well be adding just $2 each time, you see. But we want the amount that we add each time to increase over time. So the answer choice C is the only one that does that.